What if that simple little device that helps you see the world more clearly could also see into the future of your health? It sounds like science fiction, doesn't it? Well, today we're looking at some absolutely groundbreaking research that does just that, turning a standard contact lens into a super sophisticated, non invasive health monitor.
It's a really powerful question, right? Because for millions and millions of people, vision loss isn't some sudden event, it's this slow, silent process. And the absolute key to stopping it, is catching those warning signs that are, right now, almost impossible to track continuously.
Okay, so let's get right into it. The main target for this new technology is a condition that's often called the silent thief of sight, glaucoma. And it is the perfect example of a disease where the data we desperately need has been just completely out of reach. So here's the deal with glaucoma. It causes damage to the optic nerve that you can never get back. It's irreversible. A huge risk factor is high pressure inside your eye, something we call intraocular pressure, or IOP for short. Now, if doctors can keep an eye on a patient's IOP and manage it, they can literally save their sight. But there's a massive problem with how we currently measure it.
Think about it this way. Measuring IOP right now is kind of like trying to understand a full-length movie by just looking at a few random photos from it. You have to go to the clinic, a doctor uses a special device to check your pressure, and that's it. That's the snapshot you get. But your eye pressure isn't some fixed number. It's changing all day long, and this is the critical part. It can spike at night while you're sleeping. This means all those potentially damaging pressure spikes are happening completely in the dark. Totally messed by the system we have now.
So, to really get the full story, what you need is a monitor that can watch the eye 24/7. And this is where researchers came up with an incredibly elegant solution, a smart contact lens, specifically designed for continuous, wireless IOP monitoring. Let's break down how they actually built this thing. It starts with a bottom layer of soft silicone, just like a regular contact lens. Then they layer on these ultra-thin electronics. You can actually see the ring-shaped IOP sensor, a tiny little processing chip, and an antenna. And then it's all sealed up with another layer of silicone. It's a really powerful medical device, just cleverly disguised as something you wear every day. So, how does it all work? Well, when the pressure inside your eye increases, it very slightly changes the curvature of your cornea. Since the lens is sitting right on top of the cornea, that tiny flex actually stretches the sensor inside it. That stretch changes the sensor's electrical resistance. The little chip on board measures that change and then beams the information wirelessly to a device, maybe your phone. It's a completely seamless way to turn a physical change in pressure into a real-time digital signal. Now we get to the real heart of this innovation. Because a sensor that's this sensitive and this flexible, well, it needs a very, very special material. The secret ingredient here is a mesh of silver nanowires. You see, a sensor in a contact lens has a huge challenge. It needs to be electrically active, but it also has to be pretty much invisible. I mean, you have to be able to see through it. This lens achieves over 91% transparency, which means you can read text through it with no problem at all. The secret is that the sensor isn't a solid film. Instead, it's this microscopic web of silver nanowires. This mesh is conductive enough to send a clear signal, but it's so sparse that it's almost perfectly clear. But there was a major, major hurdle to overcome. Silver, as you probably know, tarnishes. It oxidizes, especially when it's exposed to something salty, like our tears. So an unprotected silver nanowire sensor would just quickly degrade in the eye and become totally useless. The team's solution was brilliant. They coated the entire sensor with an ultra-thin, transparent, and biocompatible polymer called Parylene C. You can think of it like a flexible, invisible suit of armor for the nanowires. It completely seals them off from the eye's environment, protects them from oxidation, and makes sure the sensor stays stable and reliable for long-term use. Okay, so the design is clever, the materials are all sorted out, but the ultimate question for any medical device is always, does it actually work? And this required some really rigorous testing, first in the lab and then in a living system. The very first step was to test it in a controlled lab setting. The researchers built a model eye where they could use a syringe pump to precisely control the internal pressure. They put the smart lens on this model to see if the sensor's electrical signal would perfectly, and I mean perfectly, match the pressure changes they were creating. It was the ultimate accuracy test. And the results were, wow, just phenomenal. They measured this using the statistical tool called an R-squared value.
All you really need to know is that it scores how well two things match up. A perfect score is 1. This lens scored 0.9965. I mean, that is about as close to perfect as you can possibly get. It proved that the sensor was tracking pressure with incredible accuracy. In the lab, it was a massive success.
So the next step was the real challenge, moving from a nice, clean lab model to the complex, dynamic environment of a living eye. For this part, the team turned to rabbits, which are a standard model for eye research, to perform the first in vivo, that means in a living body, wireless tests. And this, right here, this is the moment of truth. The team safely and temporarily raised a rabbit's eye pressure by having it in a head-down posture. While they did this, they measured the pressure in 2 ways, with a conventional gold standard tonometer and with their new smart lens. And the results? A perfect match. The wireless signal from the lens detected the exact same pressure. It worked. It actually worked in a living eye.
So what does this all really mean? Well, this isn't just a fascinating piece of engineering. If a technology like this makes it to clinics, it represents a fundamental, game-changing shift in how we manage and prevent one of the leading causes of blindness in the world.
So just think about the leap forward we're talking about here. We go from the old way, a few inconvenient appointments a year that give you a totally incomplete picture, to the smart lens, which offers a 24/7, non-invasive, continuous view of what's really happening. This gives doctors the whole story, letting them personalize treatment and step in at exactly the right time to save someone's vision.
And this really brings us to a final, much bigger thought. This technology is aimed at glaucoma right now, but the basic idea, a soft, transparent, integrated sensor, could go so much further. Just imagine lenses that continuously monitor glucose levels through your tears for diabetes, or detect markers for an infection before you even feel sick. This is more than just a smart contact lens. It's a real glimpse into a future where medicine is predictive, it's personalized, and it's seamlessly integrated into our daily lives.